Okay, we're into rationalizing denominators. So you have an expression, it has a root in it, you want the root to go away. A square root specifically. We don't have a lot of good techniques for clearing out cube roots or higher, but with square roots, there's things we can do. In this case, we've got 3 over 2 root 6, and we want to get rid of the root 6 so that the denominator is rational. The way you cancel out that root 6 is you multiply the top and the bottom of this fraction by root 6 again. Just the root, notice there's no need to multiply by the 2. If you do, you are going to get the right answer, but there'll be a little bit of extra work because your numerator and denominator will end up 2 times too big. No need for that. So all you multiply by is the root in this case, and then you get 3 root 6 over 2 root 36, which is just plain old 6. So 3 root 6 over 2 times 6, which is 12. You could stop there, but do you see why we shouldn't? You're always supposed to reduce fractions as much as you possibly can, and here we have 3/12. Both of those numbers are divisible by 3. If you do that, divide the top and the bottom by 3, you get root 6 over 4, and that's the best place to stop. Now, for these next two, we still have roots in the denominator, but now we have a couple of them in the form of a binomial. So it doesn't matter if both of these are roots or if just one of them is. As long as there are two terms added or subtracted, we can cancel this, but it's not as straightforward as before. You don't just multiply by the roots. We multiply by something we call the conjugate. The conjugate of a binomial is the exact same two values, so we're still going to have root 5, and we're still going to have root 2 in this case, but the sign between them is switched. So you recopy this exactly except for flipping the middle sign. And, of course, we have to do the same thing in the numerator and in the denominator. So there's root 5 minus root 2. And now we multiply all this out. In the numerator, that means we do 3 times root 5 and 3 times minus root 2, which is simple enough. And in the denominator, we're going to FOIL. Root 5 times root 5 is, it's just 5, but I'll write it as root 25 because we're doing this in small steps. This is 5, and the next time I rewrite this line, I'm going to just write it as 5, but I'm doing this to remind you what's going on. Root 25 minus root 10. From the inside, we get plus root 10. And from last, we get minus root 4. So if we clean that up, we get in the numerator 3 root 5 minus 3 root 2. In the denominator, we get 5. These terms cancel, and that's not a coincidence. Every time you multiply by the conjugate, you can expect this to happen. And then we get minus root 4 is 2. Now, this is nice. 5 minus 2 is just 3. I'll put that there. And another thing the conjugate always does is it makes this denominator always come out rational. That's why we use it. So this is very nice. And we get even luckier in this case because our numerator and our denominator are all divisible by 3. Now that won't happen every time. That's lucky. But we'll certainly take it. I will divide that whole thing by 3 and divide this by 3. And that gives us the result root 5 minus root 2. You could put it over 1, but why would you? It's so much nicer if you just leave it this way. Root 5 minus root 2. So they don't always come out this nice, but when they do, we are glad to see it. Last one, a binomial again. And so again, we can rationalize this by using the conjugate. The conjugate of this is, you recopy it exactly, except you flip this middle sign. So if the original was a minus, we're going to use a plus. And if I multiply by that, I must do the same thing in the numerator. So here we are. Okay, now we expand this 4 root 2 times 5 root 3. Remember, you do whole number times whole number and root times root. So 4 times 5 is 20. Root 2 times root 3 is root 6. Then for the next term, 4 times 3 is 12. Root 2 times root 6 is root 12. And then we do a whole bunch more of that in the denominator. 5 root 3 times 5 root 3 is 25 root 9. And root 9 is 3. We'll get to that in a moment. Outside, we get plus 15 root 18. Inside, we get minus 15 root 18. So we mentioned how the conjugate causes those middle terms to cancel every time. It's happened again. These two terms are going to drop out and vanish, and we're quite happy for that to happen. And from last, we get minus 9 root 36. Can we clean that up? Yeah, we should be able to do something with it. 20 root 6 plus 12 root 12 can be simplified. I'm going to get started on that. 12 root 12 is the same as 12 root 4 root 3. And that's good because I know what root 4 is. We'll come back to that in a minute. Downstairs, we get 25 times 3. And 9 times 6 is 54. So we're long done with the simplification part. We're just cleaning this up now. 12 times 2 is 24 root 3. And in the denominator, 75 take away 54 should be 21. Can we reduce that anymore? Unfortunately not. 21 is only divisible by like 3 and 7, which don't go... 3 doesn't go into 20, 7 doesn't go into 24, so this is a dead end reduction-wise. I don't see anything else we can do to clean it up, so there we stop. So we made a bit of a mess of our numerator, but we did get a rational denominator, and that's why we did this in the first place.